First, we calculate the fraction on each sieve by subtracting out the sieve masses. The sum of the mass retained column gives the total mass. Now this is where things get tricky, as we need to use an absolute reference to calculate the percent fractions. The sum of the percent fractions must equal 100%. Calculate the percent passing by subtracting out the fractions captured at each step. Now let's copy and paste this table so we can process the limestone results in the same way. After pasting in my results for the crushed limestone, I realise I have a problem. Let's create a new absolute reference.
رجعيين واللي ناشد نازل يد الطاسم رجعيين واللي ناشد واللي نازل يد الطاسم رجعيين واللي ناشد واللي نازل يد الطاسم.
Now to place a log scale for the x-axis. Right-click and choose Format Axis. And to move the vertical axis to the left side of the graph.
ما غرام
Let's dig a little deeper. There are 99 percentiles on the y-axis, and each one of them can be used as a point of comparison between sample 1 and sample 2. Let's use the 50th percentile, which is the median particle size, to compare the two samples. But first, to practice counting along the log scale. Counting 0.1, 0.2, 0.3, 0.4 millimeters, 0.5, 0.6, 0.7, 0.8, 0.9, 1 millimeter, 2, 3, 4. So by weight, 50% of the limestone sample is smaller than 0.4 millimeters. By contrast, with the gravel sample, it is particles all the way up to 2 millimeters before we account for the same proportion by mass.